All right, so ladies and gentlemen, Unit 3, Lesson 18, Velocity. So we are now starting to actually code our actual games. So the first piece of code that we're going to look at is called Velocity X. On the way to moving sprites in Game Lab with the counter pattern. For example, sprite1.x equals sprite1.x plus 1 moves the sprite by 1 pixel in each frame of the draw loop. This pattern is so common that the sprites have velocity X properties that does this for you. So what are we going to be doing? First of all, it says drag the sprite velocity X block directly below where you see the sprite created. So if it says show me where, it'll tell you right here. Add your block right here. So we're going to do it right after we set the animation. So I'm going to do that. I'm going to go ahead and drag velocity X over right there where it told me to. And then it says assign the write the name of your sprite in the block. The name of the sprite is fish. So I'm going to change that to fish. It says assign the velocity X property a value of 1. So I'm going to go ahead and do that. Give it a value of 1. Run the code. What happens? Okay, so let's see. If I run the code, we now see that the fish is moving, and that's all that I really had to do, which was kind of cool. And again, if I go down here into my further code, we can see that it's just drawing the sprite, and it's given that property automatically. Then it says to go ahead and change the value for the code. All right, so again, if I change the value from 1, let's say if I change this to 5, just making that up, and I hit run, you can see that clearly it's moving faster. So this can replace a lot of that much more complicated velocity that we have been using. All right, so that hopefully will get you through bubble number 1. As always, when you're done with the bubble, make sure you hit finish. All right, here is our buddy. Oh, come on, full screen.
I'm originally from South Carolina, and now I'm all the way over in California in Silicon Valley. And here, software is all about optimism. It's not just a means to an end. It's this thing that gives us hope to solve every problem that the world potentially has. Moving your sprites around the screen means using a very familiar pattern, the counter pattern. This pattern lets you add to the position or rotation of your sprite on each tick of the draw loop, so it looks like it's moving or rotating at different speeds. Here's an example we've seen before. Using the counter pattern with the sprite's X property, we can control a sprite's velocity, how fast it's moving in a particular direction. If we add a larger amount to the X position, the sprite looks like it's moving faster. Adding a smaller amount makes the sprite look like it's moving more slowly. You've been using the counter pattern to control a sprite's velocity a lot. In programming, when the same pattern happens many times, you can often hide those details inside another block. In our example, that block is velocity X. The velocity X property hides the details of the counter pattern that changes the sprite's X position. Whatever number you assign to this property will automatically be added to your sprite's X position on the next tick of the draw loop. This program creates a sprite, gives it an animation, and then draws it on the screen. Now let's give that sprite a velocity by setting its velocity X property to 1, just once at the beginning of the program. When we rerun the program, we see that the sprite's position is updated. Under the hood, the velocity X property and the counter pattern are used to update the sprite's position, moving it across the screen. The other new properties that work in a similar way are velocity Y, which controls velocity in the vertical direction, and rotation speed, which controls how fast the sprite rotates. The under-the-hood behaviors of velocity x, velocity y, and rotation speed are all things you've tackled in previous lessons. Now, we get to let those blocks handle the details for us and explore new ways of moving sprites on the screen.
All right, so pretty much what we're saying here then is that this new code that we're looking at now.
Now let's learn about a programming concept called events.
Sorry.
An event tells your program to listen for something to happen and then react right away.
All right, sorry about that. All right, so this new code, in other words, is going to simplify our ability to give our sprites motion. So instead of having to do that whole ladybug x dot equals ladybug plus 1, 2, 3, whatever, 17, we now have one bar of code that can do this for us. So it helps to simplify things. As always, you can always come back to this video if you need to later on. All right, so let's take a couple of looks. All right, so it says moving down. Here's a feather sprite that should be floating down the screen if velocity x makes the sprite move to the right. Can you find the block that will make the feather move down? Do this. Find the block that will make the feather sprite go down the screen and use it outside of the draw loop. And again, if you need to know where, you just click this show me where, and it'll show you right here where to add your block. All right, so if I go ahead and hit run, my feather is just kind of sitting there. That's not awesome. So I want this to move it down the screen. So again, if I turn on my grid and I want to go down the screen, what I'll notice, thank you, is that my y property is changing. So I want to change the velocity of the y. So I'm going to go ahead and drag this in right there. And the first thing I'm going to do is I'm going to change the name of my sprite to feather, which I spelled correctly, I hope. Yeah, that looks about right. All right, and then I need to give it a value. So I'm going to go ahead and give it a value of 1. And remember, I want this to go down the screen. So I'm going to go ahead and hit reset and run. And that's exactly what it's doing. Now, if I wanted it to fall faster, I could give it a larger value than 1. If I wanted to go slower, I, of course, would give it a decimal point value. All right. So any questions on what I've just done? Go ahead and unmute yourself because I cannot see the chat while I am screen sharing. Any questions at all? All right, cool. So go ahead and hit finish. And as always, please do make sure that you hit finish or continue or next, whatever that orange button is, when you are done with the bubble, because otherwise it doesn't get sent to my teacher, the teacher side of things. All right, so now we're going to take a look at rotation speeds. We looked at changing the x velocity in the first bubble. We took a look at changing the y velocity in the third bubble. And now we're going to take a look at rotation speed. So we can use rotation speed to make our sprites spin. If you want your sun to rotate by 2 degrees every time it's drawn, then you can use rotation sun dot rotation speed equals 2 before the draw loop to create and after you create your sprite. So we're going to make it rotate by 3 degrees every time it runs. And again, where does that go? Right after we create and animate our sprite. So I'm going to go ahead just like before. So if I hit run, right now my sun's not doing anything. That's not cool, not good at all. So I'm going to go ahead and grab my rotation speed, drag it in. I am going to go ahead and change the name sprite to sun because that is the name of my thing, name of my animation. And again, it tells us to do this a rotation of 3 degrees. So I'm going to go ahead and hit 3 as my value. So what this is saying is that every time I draw this sprite, I am going to give it a rotation of 3 more degrees, and I don't have to do all of that crazy stuff I was having to do before. This is definitely going to help to simplify our programming. And now you can see that that's exactly what happens when I run my program. Of course, if you want it to spin slower, give it a smaller number. If you want it to spin faster, give it a bigger number. But that is personal choice for when you do your own creations. But for the purposes of this one, of course, it asks us to do it at 3 degrees. Any issues or questions? All right, hearing none. Always make sure you hit finish or continue on your bubbles once you complete them. All right, controlling the speed. So now that we've used rotation speed outside of the draw loop to make your sprite rotate when your program started. You can also use rotation speed inside of the draw loop to change the speed of the sprites during a game, which is, you know, if you play games, you know that sometimes you need to change the velocity of things inside of a game. For example, a sprite can start rotating when the user presses a space bar, and it will keep rotating until it's told to stop. Okay, so now we're going to get into our conditionals. If you guys remember those from when we were programming before. It says, look at the if statement inside the draw loop that checks whether the spacebar has been pressed. So it says, show me where. If you can't figure it out, just go ahead and click that. And it tells you exactly where. Use the rotation speed block to make your color wheel start spinning when the user presses the spacebar. So again, if I run this right now, nothing's happening. If I press my spacebar, nothing's happening. All right, so what I'm going to do is I'm going to grab my rotation speed. I'm going to bring it inside my conditional. Let me get rid of this so it's a little easier to see. Let's make it, I don't know, let's go with 2 because why not? So now what I'm saying is my sprite rotation is going to be 2, but this is only going to happen if my spacebar is pressed. Okay, so I'm going to go ahead and hit run. I'm not currently pressing my spacebar. Nothing's happening. However, once I press my spacebar, oh, nope. Oh, I know what I forgot to do. I forgot to change the name of my sprite. My bad. See, even the teacher makes mistakes, and that is perfectly okay. That is what programming is about. Learning from your mistakes. Okay, so now that I've changed the name of my sprite to wheel, again, I'm going to hit start. I'm not pressing the space bar. Nothing is happening. But once I hit my space bar, my wheel starts to rotate. Now, it's not stopping, but that's okay because I haven't programmed it to do that yet. Remember, computers are kind of dumb. They only do what you tell them to. I'm going to go back to my instructions to make sure I didn't miss anything. Nope. Looks exactly what I've needed to do. Awesome. So that is my bubble number 5. Once I press a space bar, it starts to move. Kind of like when you are using your games, when you press certain buttons, objects do things inside your games. Make sure you hit finish and continue. So then that bubble number 5 gets sent to the teacher side of things. All right, bubble number 6, changing velocity with position. Okay. So this is one of those that we have to make a prediction before we before it'll let us run the program. All right, so it says one advantage of using the velocity blocks inside conditionals is that your sprite keeps moving even after the condition stops being true. For example, you only had to press the key once to start the color wheel spinning, and it just kept spinning forever. The code below uses if statements to make a fish sprite move in different directions. Do this. Look at the if statement and check the sprite's position and its set velocity. With your partner, which obviously is going to be me, discuss what you think the code will do and write your answer below. Once you have submitted your answer, you may run the code. All right, so I'm going to take a look. It says if the fish's x is less than 0, then the velocity is 2. If the fish's X position is greater than 400, then the velocity is -2. So I'm thinking if the fish tries to go less than 0, and remember, our grid only goes from 0 to 400. So I think what it's telling me is that if my X goes lower than 0, then it's going to have a velocity of +2, right? But then it says if the X goes greater than 400, so in other words, if this thing is moving, and it tries to go bigger than 400, then my animation is a different animation. It says fish L. I'm not sure what that means. But then it says fish velocity is -2. So I think that this conditional will help keep my fish on the screen. I have no idea if I'm right or not, but we will find out, because once you make your prediction, and again, the only way to make a prediction wrong is to not do it, we're going to go ahead and hit run. All right, so there goes my little fish. It hit 400. Oh, and he turned around. Oh, okay. So that's why we have the two different animations. So one that says fish R and the one that says fish L, we're actually changing the animation along with the position. So it actually looks like the fish turned. Oh, that is cool. All right. I'm done being a nerd. I promise. All right, cool. So we just kind of figured out how to make things stay inside the grid. Nice. And even changed. I'm totally being a nerd right now. This is kind of cool. All right, so I'm going to go ahead and hit finish on this because, again, the purpose of this one was just to do a prediction. All right, so now, ladies and gentlemen, let's see. It says back and forth. This ball bounces back and forth when it hits the bottom of the screen. Can you make it bounce back when it hits the top of the screen? Do this, run the code, and see how it works. Look at how conditionals and velocities are used to make the ball bounce at the bottom of the screen. Add code to make the ball bounce at the top of the screen. Okay, cool. Let's see what happens. First of all, do I need to do anything? Nope, it does not require any kind of user input. Awesome. All right, so I'm going to make this a little bit bigger so it's easier to see. Go ahead and hit run. Boing. It bounces. All right, and it doesn't come back. All right, that's not cool. All right, so I'm going to go ahead and reset this. So I need to figure out a way to keep, so when the ball gets to the top of the screen, I want it to be able to return towards the bottom. Okay, awesome. So I'm going to go ahead to my control section, and I'm going to bring in a conditional, and I'm going to put it under my other conditional. And I am going to say that if my sprite's Y position, oops, nope, sorry, my bad, I need some math. That's right, the top is 0 for Y. So if my ball position is less than or equal to, okay, so we'll go with less than. So I'm going to say if my sprite's Y position is, it says, it looks like this one stopped 20, so I'm going to say is less than 20. Then what will happen? My sprite's Y velocity will be +5. And I need to change my word sprite to ball. Okay, so let's see now. So it bounces and hits. Bounce. Ah, look at that. All right, so I have two conditionals. One says that if my ball's Y position is greater than 380, then we're going to give it a negative y velocity. However, I have a secondary conditional in there that says that if the ball's y is less than 20, then the y velocity of the ball is positive 5. And that action will keep it going back and forth ad nauseum. So, yay. And again, if this was like a fish where like the direction matters because it's a ball, like it doesn't matter if it's going right or left, we would even be able to change the animation or set the animation differently depending on what direction it was heading, just like we saw in bubble 6. All right, go me. Awesome. Okay, so ladies and gentlemen, we have not too much longer left, but your project now is to get through bubble 8, both A and B. And then, of course, you will complete bubble 9, which is controlling fish movements. So bubble 9 is you need to get it to swim left and right. Again, this is for you to do independently. And as always, the challenge bubble is 100% optional. All right, so let me go ahead and stop the recording.